I've got Dungeon Master's Guide. I've got 12-sided die. I've got Kitty Pryde and Nightcrawler too, waiting there for me. Yes, I do. I've got posters on the wall. My favorite rock group, Kiss. And the ride.
Developers, please welcome to the stage Brad Calder.
All right. Good morning. Welcome to the Developer Keynote. We have an exciting show for you today. Yesterday, we introduced the Gemini Enterprise Agent Platform. It allows you to build autonomous agents that proactively help users and complete tasks independently. And today, we'll show you how to use our agent platform to build production-ready agents. Our agent platform is powered by the state-of-the-art Gemini models, which includes both our Pro and Flash models. In addition, you can choose other models for your agents like Claude from our model garden. Now, let's quickly walk through what our agent platform provides to help you build, scale, and optimize agents. It starts by building agents with our Agent Development Kit. Our Agent Development Kit lets you power agents with the skills and the tools you need. We provide ready-to-use skills across Google Cloud. And every Google Cloud service is now MCP-enabled by default. Yeah. This allows agents to easily communicate with Google Cloud. Then we run and scale your agents with our scalable serverless agent runtime. With our agent runtime, you can use sessions to keep agents connected with your users and memory to personalize and focus the context for your agents. Now, to keep all this secure, we enable you to govern your agents by giving them a unique agent identity. This allows you to enable policies for agents that are strictly enforced by our agent gateway. Now, one of these policies could be to connect with other agents, where we allow agents to be discovered and collaborate with each other with our agent registry and our A2A protocol. And finally, agent observability allows you to manage, monitor, and optimize your agents. This also provides integrated evals based on what your agent is doing in production. Now, all the capabilities I just went over are provided by our Gemini Enterprise Agent Platform. And at Google, we are building our own applications on our agent platform to allow you to connect and govern all agents with a common shared context. We provide this shared context across Gemini Enterprise, Workspace, and third-party marketplace agents. This allows your entire ecosystem of agents to collaborate with each other with shared context. Now, I'm an avid runner, so I'm very excited about our keynote demo. Today, we'll show you how to plan a marathon, you don't have to run it, through Vegas by building an agentic marathon planner, using everything I just described from our agent platform. Now we can use AI to make high-stake decisions, like where to place 500 porta potties across the Vegas Strip. And to guide you through all this, please welcome our Emcees, Richard Seroter and Emma Twersky.
Thank you, Brad, and welcome to the show, Emma.
Happy to be here, Richard.
Yeah, are you a runner? Brad talks a lot about running.
I ran a half marathon once, and that's it. What about you?
No, running's awful. I don't know why anyone does it, unless they're being chased. But look, the role of the software developer is evolving a lot. We have to think about new ways to work. In 2026, you all are building applications in days that would have taken weeks or months just a couple of years ago. We're even doing it faster here at Google, too.
We are. Talk about fast. I've been blown away by all of the insanely talented developers right here in this community. Over in DeepMind, Andy Koonin used Gemini to transform complex geographic information system data into a nostalgic 90s-style isometric map of all of New York City. By transforming thousands of pixels into art, we can now learn, visualize, and comprehend data sets that I just sort of assumed I'd never be able to.
Absolutely. Or the team at Cloud Physician, they're part of the Google Startup Accelerator in India. They built this multimodal video AI platform built on Google Cloud. It combines high-definition video with AI-powered clinical tools. What it does, it connects these bedside teams to this 24/7 central care team and empowers specialists to do faster, higher-quality decisions. And get this, they've actually driven a 47% reduction in ICU mortality, literally using Google Cloud and Google AI to save lives.
Yeah,
Awesome.
I can't get over that number, Richard.
Yeah.
And as a Flutter developer, personally, I've been cheering on Chatai Ulasoi, a Google developer expert in Finland. While studying for his citizenship exam, he built a generative UI-powered language learning app. The app uses my team's Flutter Gen UI SDK, plus Firebase and Gemini and a whole lot of other Google products to create and personalize how users learn language.
Yeah, maybe I can finally learn Elvish.
Open a pull request.
Yeah, I'll do that. Personally, I've been having a lot of fun with Genie 3. These world models are transforming how we approach development. Waymo actually uses Genie 3 to recreate edge case traffic situations, which in turn helps it train those foundation models in that quest to be the world's best driver. Here's a prompt and experience I made to explore Las Vegas before I got here. If you look close, there's like an off-brand Bluey fighting like a knockoff Spider-Man. It's super real, just like Vegas. But I'm really stoked for everyone to see what these demoers have been working on. This stuff is amazing. We can say a lot of stuff. We need to prove it to you. So we're going to demonstrate how Google offers the best way to build agents and then run them in a production-grade way. Emma, what are people going to all see here over these next 50 minutes or so?
Yeah, so we've talked about it a lot, but we're building a system to simulate planning a marathon. Ask me why.
Tell me why.
Well, a marathon is a great example of how agents can help us to plan, simulate, and think about solving a really big challenge, like trying to plan a race here in Las Vegas. An event of that size would impact traffic, it'd potentially reroute emergency services, and we'd also want it to boost local economy and showcase all of Las Vegas's iconic landmarks. There's a ton of factors that we would have to consider.
A lot of factors, and with agents, we can actually build simulations quickly to better understand the actual impact of something like a race to a city. Agent systems simulate actual behavior instead of hard coding those behaviors or relying purely on probabilities. Our system's going to use 3 main agents. We're going to walk you through this. There's a planner that determines all the routes that we run. There's an evaluator that assesses those routes based on business and community requirements. Then there's a simulator that takes the route creates all these actors via code and then randomized behaviors to see the net impact to the city.
Yeah, let me show you what we're building towards.
Yeah, the magic stage just came up. All right.
All right, so here we are in our simulation app. And if I start this, we can actually see the Las Vegas skyline light up.
Amazing.
If you look closely, you can actually see us giving the keynote, I think, right down here.
Exactly true. I could see me. I look terrified.
All right, so we have a plan for a proposed route for a marathon in Las Vegas at night. Because let's be real, the Vegas skyline comes to life after dark.
So do most of my bad food choices with Scott. Yeah,
Or your good ones?
sometimes.
All right. And while I click Run Simulation, we can actually talk about how we built this. So I was on the Angular team for 5 years, and that's what's actually powering the base of this app and all of the 3D animation that you're seeing here today, showing this rendering.
Yep, we love Angular.
Now I'm on the Flutter team, and all of this sidebar you can actually see being powered by ATUI and some of the Gen UI ideas that you'll see later demoed today. And here we have it. Our simulation is off. So I can actually click Follow the Leader and see our simulation in action. We can see 10% of a sample of our runners starting their race. The planner agent carefully planned this route, and if I click I'm feeling lucky, maybe we can see some of those other hydration stations, medical tents, and things that the planner agent helped place. Meanwhile, our simulator agent is helping to create a realistic race environment. So it even placed all of those cars that you see navigating the Las Vegas traffic.
They're going faster than our cabs last night.
Way faster than my Uber here this morning.
That's not real.
It's simulated.
Simulated.
And there's one more thing I want to show you, which if I actually navigate over to the Organizer tab, I can see some of the simulations that we ran before getting on stage today. And if I click Open Report, I can see how those simulations scored when exposed to all of those non-deterministic conditions that we've been talking about.
Yeah. All right, so I bet the audience, though, is ready for the real behind-the-scenes look. Now that we've seen what we're building towards, we want to rewind and show how we built this, starting with that planner agent. During this series of on-stage demos, we'll reveal the details of how we build agents in 2026, all the techniques we used, and the products that help us deploy agents to multiple surfaces. And get this, everything we're showing you is sitting in a GitHub repo right now that you can use to reproduce this entire app yourself. The app we're giving away for free. How amazing is that?
Open source.
Yeah, there you love it. So to kick us off, how about we get a little rally towel action for my man, Mofi Rahman? Let's go.
Thanks, Richard. In this demo, you will see how to go from agent idea to proof of concept with our agent platform. From our agent platform, we'll use ADK as our agent framework for building modular agents, Google Cloud Remote MCP, or Model Context Protocol servers, and Agent Runtime, our runtime for agents. Our simulation application has a few different agents. One of the core pieces is the planner agent. Now, the planner agent needs to have the following: instructions to help the agent understand its role as the marathon planner, skills for using maps, handling geospatial data, and expertise at planning a race, and tools to help with mapping and calculating viable routes. We started by designing a basic planner agent in Agent Designer. We can design low and no-code agents and even preview their behavior. This makes it easy to try out different agent ideas. We have given the agent some instructions on marathon planning that we crafted with Gemini's help. Let's run this and see what we get for a sample marathon planning prompt. The agent will take a few seconds to come back with a plan. You know, it is so much fun building agents with everyone watching over me. I am just glad I only have to plan the marathon and not run it. Okay, looks like we have a result. And it's a good start. Using Gemini's knowledge, we have a decent amount of detail for planning a marathon. Now let's ground this plan to real data by making the agent an expert with maps and races. We achieve that by adding tools and skills. We can download Python code that was pre-populated by Agent Designer with instructions. This will be our starting ADK code. And we will continue adding features with code editing tools. Let's show you how the rest of our agent works. First, we need to give the agent access to map data. We gave access to mapping tools using Google Cloud MCP Server for Google Maps. Here are the few lines of code that connect the agent to Google Maps MCP Server. Google Cloud MCP servers let your agent access any tools that you register. You can also use first-party tools designed and built by Google, where security is included by default. Now we can ask map-related questions, and the agent will be able to answer them using the Google Maps MCP tool. For example, we can ask for a list of landmarks in Las Vegas, which we can use to plan our route. Next, let's talk about skills. A skill has two parts, the YAML metadata and the markdown body. The metadata is loaded into context in the beginning. It contains a description which lets our agent know when to load the rest of the skill. We have 3 skills for our agent. Let's look at the mapping skill to see how it makes our agent an expert at using Google Maps. It can selectively call the maps tools based on the agent loading the skill. We also have a GIS skill in the same structure to handle geographic information. This skill also has access to Python scripts that our agent will be able to execute and process GeoJSON data and find a viable route with good starting and ending locations. Last, we have the race director skill. Here, we have a Google Doc that our race planning committee uses to plan and check routes based on our historical knowledge of the requirements. Using Gemini, we converted that to a skill. I love how easy it is to take our existing process docs and make them usable for our agents. And here it is. It follows the same formatting as the other skills we highlighted. With that, this agent is ready to ship. It will take 4 to 5 minutes to deploy to agent runtime. And as all of you are my new best friends, I'm not going to make you wait. So let's hop over to a version I deployed earlier. Here it is in our simulation that Emma showed us earlier. We have given the planning agent a prompt, and we will shortly see the agent is loading skills we provided and executing the tools we included to find viable routes. Skills help the agent progressively understand what is available to the agent to complete the work, reducing turns and tokens. Looks like we're done, and we can see the route rendered. The simulated route looks beautiful. Looks like the runners are going to get an amazing view of the entire Las Vegas Strip. Let's recap. Starting from a low-code agent built in Agent Designer, we improved our initial agent. Now it has the skills and tools needed to create route plans for our marathon participants. Thank you.
That was a great demo, Mofi. Thank you for that. You may have noticed Mofi didn't use local MCP servers. By default, Google Cloud provides these fully managed MCP capabilities for many of our products. So you get the benefits of using an MCP, but Google takes care of things like security requirements, even designing all those specific tools you need. In this example, like me, you don't have to be an expert in Google Maps. MCP for Google Maps gives your agent mapping tools out of the box. If you want a closer look for each demo you see today, we actually have a QR code you can scan to do a code lab and learn about all the concepts we just introduced. And we'll share a link at the end for all the simulator code.
Yeah, I love that. Okay, so we have the planner agent that Mofi just helped us create, and that's a good start.
Sure.
The planner generates the route and looks at some of the characteristics about race planning, but we'd probably want a more robust evaluation. And then we want to be able to see what happens when our simulation actually runs.
That's why we want to separate the concerns by creating a team of agents based on the use case, the access they require, the capabilities they need. And in a simulation, a set of specific agents makes more sense to distribute all those different responsibilities. They're just like a team working together.
Just like you and me.
Oh, there you go.
Okay, so let's talk about 2 agent platform components that make it easy for our agents to talk to each other. First, A2A, a universal protocol for how agents advertise their capabilities and communicate with each other. Second, agent registry, where our agents, get this, Richard, they get registered.
Shocking.
Groundbreaking.
Unbelievable.
Agents can search the registry and discover other agents with skills and capabilities that might be needed to complete the task at hand, all using an A2A card. To show how we can build evaluation systems with agents that work together, please help us welcome Yvonne Nardini and Casey West.
What's up, nerds?
Let's go!
Right. Today, we're going to show you how to move from fragile, unpredictable agentic loops to a rigorously evaluated network of experts that will literally build their own UI.
So far, Casey, we talked about the planner agent, which creates potential routes for arrays. Now, we have two more agents. The evaluator sub-agent to judge routes based on some specific criteria we pick, and the simulator agent that works with the planner to get approved routes, run them, and show results.
Well, let's have some fun. I just kicked off a prompt to plan a marathon in Las Vegas for 10,000 runners. And now the planner does two new things: real-time evaluation to prevent agent drift in the marathon planning, and dynamic UI for instant evaluation feedback.
While the agent is running, Casey, let me explain how we build the real-time evaluator sub-agent here. It uses a separate model and limited context to judge a route. It focuses on grading only the route plan rather than the entire process. And each time we create a new plan or revise an existing plan, the planner agent invokes the evaluator just as a tool.
So in this system, the evaluation checks non-deterministic criteria like community impact and alignment to the prompt, and deterministic criteria. You know, the route has to be exactly 26 miles and 385 yards long. But for those of you who are using kilometers like Yvonne and 95% of the world, it's not easier. It's 42.195K. It's so specific.
Nah, Casey, I prefer miles. You know, 42 sounds so much farther to go.
I'll give it to you.
So now we have the planner, which creates a plan, packages it up, and sends it to the evaluator to score it. But Casey, we still want to show the evaluation results to the user. And in the past, it meant writing a lot of custom code or dashboards. And you know, I never been good in UI development.
I hear you, Yvonne. It's such hard work, but thankfully, we have a great solution for this: A2UI, or Agent to User Interface. And it's an open standard created by Google. So let's look at this result. The agent dynamically built each component to share with us and rendered this route on the map. But let's look at how this UI was prompted. Here, we use a one-shot A2UI example so Gemini knows how to generate its interface. A2UI gives our agents the power to create dynamic, expressive UI that moves beyond walls and walls of text. It's what lets the agent design and build the exact interface it needs using a common design language.
OK, Casey. So now we have our evaluation results, as we can see here. But still, we need to run the actual plan. And this is where the simulation agent takes the lead of the process. It executes the time lapse of a marathon with thousands of runners. But still, we need to connect the simulator with the planner so they can work together. And to accomplish this, we need to introduce two additional components: the agent-to-agent protocol, or A2A, and the agent registry.
And these work great together, so let's get into it. I'll start with A2A. This is a protocol Google created and donated to the Linux Foundation that eliminates brittle API code to connect agents. So each agent exposes an agent card, like we see here, representing a manifest of the agent's capabilities. The simulator agent will serve this agent card so other agents can read it.
And for all of you, if you don't want to look at this code, but still, you want to have an idea of which agents are now deployed and how they are connected, we have the agent registry. So think of it as the DNS of your Internet of Agents, the central directory that resolves every agent's identity and maps their specific skill sets across your entire agent network. When we deploy these agents to the agent runtime, they get registered automatically in the agent registry. So now that both planner and simulator are finally connected, we are ready to plan and run a new simulation, Casey, with zero code or API contracts.
Well, to see it in action, we're back here at our UI. And we can see that the planner agent consulted the evaluator and simulator agents to make a plan. So our agents are working together.
And you love to see that, right?
Right? Right. Well, our simulation is ready, so let's kick it off. I clicked Run Simulation, and now we're cooking a new one. And we can even follow a runner when they get running. How cool is that?
This is so cool, by the way. How does it work?
I have no idea. No, I'm just kidding. The simulator agent configures environment parameters. It spawns runners as independent agent sessions. It watches for traffic problems, too, and reports the results back to the planner. And for the runners, we use Gemini Deep Research to learn about and implement real-world running behaviors. Yvonne, did you know that 78% of marathon runners slow down a little in the back half?
I do know that, Casey, because I was one of them.
Well, I've only ever run one 10K, and that was enough for me.
Of course it was.
Okay.
But let's wrap up. So what we have at this point is real-time evaluation, so agents stay on track, dynamic UI, so agents render for themselves, and automatic connections using A2A and the agent registry. So our agents are doing our work. I think we are good, Casey. Let's go back to talk about cool stuff, like coffee or maybe the next marathon.
Or only coffee.
Thank you all. And let's go, Richard and Emma.
There you go. Give it up to Yvonne and Casey, two of my favorite nerds. I don't know about yours, but.
Absolutely. You know, I've been playing around with ATUI and the Flutter GenUI SDK a ton, and it's amazing to see how agents are working together to truly level up user experience. But now we need to take the learnings from each simulation and optimize for the next run.
Right, that's the important next step. In the past, we've done this by stashing the complete history of those prior runs into every next request we make, but we've moved beyond just cramming raw text into every request we send back to agents. Now we have architectural approaches, database tools that allow us to access, do this in a more efficient, thoughtful way. We have more things available to us.
We do. Context engineering is all about managing what information the agent has available in addition to its own generalized knowledge to complete the task. It's all about moving from stateless to stateful agents and context windows. Agent platform sessions gives us the ability to make our agents stateful over time and modify that context as needed.
Yeah, and then the memory bank comes in to give our agents the ability to pull learnings from prior events into the context window that are relevant for a specific task, and even to store memories the agent learns for any future session. And we can use tools like Spark or AlloyDB that provide additional context to our agents using a differentiated data approach with retrieval augmented generation.
Love RAG. And so much easier. Yeah. Managing context is all about the data you bring to your agents to give them your superpowers. And I know just the people to talk about their superpowers and context and memory for our agents. So please help me welcome Lucia, Subatin, and Jack Wotherspoon.
Alrighty, Lucia, let's do this thing. We're going to show you how context and memory improve agent behavior.
Let's use the planner agent as our example. We'll improve its context by giving it the ability to manage its sessions, add memory, and access other data sources. Jack, take it away.
Let's jump right into leveling up our planner agent. Here, we're in anti-gravity. Look how easy it is to set up session and memory management in our agent. It's less than 20 lines of code. Easy peasy.
Lemon squeezy. You can see we're adding an ADK class to integrate agent platform sessions. This gives us the ability to make our agents stateful over time and modify context as needed. We can do the same thing for memory, attaching the agent to agent platform's memory bank, an enterprise-ready and fully managed memory service.
So, the next time we plan a route, the planner agent will remember details from previous plans it created. The memory service will automatically create memories based on how and what we use the planner agent for. It can even analyze completed simulations and store learnings to long-term memory for future plans to use. Now, let's bring even more data to our agent. There are a ton of local rules with the city of Las Vegas and the state of Nevada. Lucia, how can we bring this additional unstructured data to our planner agent?
I'm so glad you asked. I want to show how data scientists and engineers can use IDEs with their workflows. These files are stored in many different structures and file types. To make this useful, we need to chunk the documents and transform them into embeddings, which are numerical representations of the text. The planner agent can query the text and embeddings using retrieval augmented generation, or RAG. Here, I prompted the data engineering agent to create a data pipeline to manage our SQL artifacts and orchestrate the document processing from a prompt.
The data engineering agent writes data models and pipelines from the prompt. It integrates with your code to bring software engineering practices to data engineering.
That is right. And now I'm using Lightning Engine for Apache Spark, an optimized engine that runs Spark lightning fast. This process reads each document and chunks it semantically using Document AI. So now we have quickly processed the chunks and saved them into this table in AlloyDB. Let's see the chunks.
All right, I can see the embeddings, but I want to focus on something super, super cool. We didn't have to create the embeddings manually. AlloyDB's auto embeddings feature will generate them for you based on the model that you specify.
And we can also see them in action. I'm running a semantic search for restrictions for running a race on the Las Vegas Strip, and I added a filter for the city of Las Vegas. This will search the embedding space for the top results. And Jack, did you know about this rule? You can't have a camel on public roads.
Oh. You don't happen to know what the return policy on a camel is, do you? At least now our agent will be aware of our camel restrictions. So now we just need to plug this knowledge into the planner agent so it can incorporate the traffic rules into the designs of our marathon route.
I got ahead of this and extended a scale from the official Google Cloud repo to make the agent an expert at using AlloyDB and vector functions. I also added a tool to our planner agent that's committed to our code base. The agent uses these to call AlloyDB through a Google Cloud Remote MCP server. So Jack, shall we switch back to you and test our changes?
Let's do it. Let me open the simulation. Here's a previously planned route. We've rerun it now that we are managing context better and have added memory. Let's see how it looks.
Now the planner agent keeps track and has access to the latest context, like what landmarks and the current route passes by. And now local rules are being fetched as part of the planning process. Taking a look at the message history, we can see that the planner agent recalled the previous detail pulling from its long-term memory of past simulations.
And Lucia, check out the difference here. The gray line is where we started, but the colorful one is our new path.
By managing context efficiently and adding memory to our agent, you can see our simulation adjusted its route based on the memory and data it now has.
Thanks, everybody.
That was great. Give it up for Lucia and Jack. That was a lot of camel content. Like, too much camel content.
It's camel engineering.
Don't even try that. It's all about context engineering, and it's exciting to see how these systems work together to make our agents more intelligent.
They do. So we have our full simulator actually built out, and we can run those multiple simulations. It's really cool to see the full thing in action.
It is, but you've been driving this whole thing, so do I get one shot?
Yeah, go right ahead.
Because now we have a simulation engine that has all this data component, has all these pieces, and so now when we run one, we can get that past history, all those memories aligned together, and everything just works. Son of a nutcracker. What did you do on that one?
That was your bad.
That was you. That was me. I had one job. All right, cut it out back there. That's a lot of sirens. There we go. Thank you.
So here's the thing, Richard. It's not your fault.
Oh.
As we know, things break in unexpected and new ways when we start to introduce LLMs.
I know. One issue we did run into in development is related to how context ends up being managed when all these tools get executed. There's a lot going on.
There is. So let's talk about two things here that are going to help speed up our ability to debug agentic behavior and fix our apps faster than ever. Agent observability, which gives you visibility into operational metrics for agents based on open standards. And Gemini Cloud Assist, our agentic cloud operator that helps with managing your agents from design to run to fix to optimize.
Yeah, I need someone to bail me out. There's only one person I trust to get this unstuck, so please help welcome to the stage Megan O'Keefe.
Good morning. Let's talk about debugging agents at scale. With these autonomous systems, the production challenge isn't just scaling the infrastructure. It's managing the reasoning, the tool calls, all the places in the whole system where something can go wrong. And in these environments, unexpected errors do happen. Today, I'm going to show you how to fix those issues. We will use agent observability and the Cloud Assist investigations agent to dig into a simulation agent error on agent runtime. We will find and isolate the root cause of the error. Then we will deploy a proactive fix, all with natural language. Now, our simulator agent needs to manage a lot of context for the live simulation. To prepare for this, I've added context compaction to that agent. This feature, called Event Compaction in Agent Development Kit, tells our agent to periodically summarize its workflow using Gemini, reducing the total context that's sent to the model at each turn. Now, I deployed this optimization, but we all just saw Richard break the simulation, and I would like to blame him, but Google has a blameless culture, so let's just investigate here. Here in Gmail, I can see the alert firing. The simulator agent is experiencing unusually high latency. Let's click View Incident to open up the Cloud Monitoring console. OK, so the simulator agent's taking a really long time to run. It's not returning any responses, but it's hard to see exactly why in this view. Let's figure out what's happening under the hood by opening the agent runtime trace view. Now, traces allow us to see the agent's underlying tool calls and reasoning flow. Here I can see that the agent is successfully calling multiple tools, but then it crashed all of a sudden. That's pretty strange. Oh boy, these logs are dense. You know, before I would be panicking, copy-pasting things desperately, but now watch this. I can click one button from the error log and start a Cloud Assist investigation. Gemini Cloud Assist is an AI assistant agent that helps you design, deploy, troubleshoot, and optimize your workloads. Now, this investigation took a few minutes to run, so I've preloaded it here. We can see how Cloud Assist has gathered the logs from the agent and closely examined the agent runtime infrastructure. It looks like the simulator agent is failing to call the Gemini Model API due to a request error. Something is wrong with the payloads we're sending to the model. Now, helpfully here, Cloud Assist is pointing to a specific line of our agent simulator code, so let's open that up and keep digging. Now, here's something pretty cool. I can open my IDE, in this case, anti-gravity powered by Gemini 3, and continue the Cloud Assist investigation I had just started in the console. This is because my IDE is hooked up to Cloud Assist through MCP. And Cloud Assist is one of many Google Cloud products with a built-in remote MCP server, ready for all of your AI applications. So from the agent, I've asked, resume the Gemini Cloud Assist investigation about the simulator agent. What is going wrong in agent.py? Now, this prompt takes a minute to run, so I've loaded it here. We can see how the agent is using the findings from Cloud Assist, looking closely at the agent source code. It's even searching GitHub for relevant issues. And look at how the agent synthesized all that information into a clear explanation of what's going on in our code. It seems that the reason we're seeing this 400 error is because we are exceeding the Gemini API's 1 million context token limit. That event compaction that we added to our agent, it is not running often enough to compress the context in between these huge tool calls. Now, here's what I really love about using agents during the debugging process. They don't just find the root cause of the issue. They suggest a proactive code fix to patch the issue. Here, the agent is suggesting that we add a token threshold parameter to our event compaction config so that we are periodically compressing context more often within each invocation. Now, from here, we can approve those changes, view the code diff, and commit this change back up to source control, triggering our CI/CD to redeploy the simulator agent back to agent runtime. That entire process takes about 5 minutes to run, so I pre-deployed it here. I'm back in the agent runtime console, where I've rerun the same query in our patch simulator agent. And we can see that despite exceeding that 1 million context token limit, our simulator is now running without errors, with event compaction running successfully. You know, this whole debugging experience shows that agents like the simulator are still just software. Operating them safely requires transparent metrics, the right debugging tools, and careful attention to scale. And not just infrastructure scale, but things like token scale. Google Cloud uniquely provides a full observability suite for your agents. Cloud Assist and your coding agent don't just identify issues in these systems. They proactively fix the problems that they find. So with the right tools in our belt, operating agents gets a lot easier. Thank you.
There we go. Nice work, Megan, bailing me out again. Thank you. The right tools make it a lot easier for us to pinpoint the root cause of a failure in these distributed multi-agent systems. In this case, anti-gravity and Gemini Cloud Assist trace that cascading failure from our initial agent crash all the way down to the bug in the code. That's awesome.
Yeah, I think something that a lot of people say is the best code is working code.
That's beautiful. Is that Shakespeare?
No, it's Gemini.
Okay.
So here's the thing. The first architecture usually isn't the final one.
Sure.
In fact, for me, it rarely is. When we build applications and AI systems, we want to start small. So we learn about how AI works and what new things it helps or breaks. From there, we evolve the architecture based on our needs. We might swap out runtimes, databases, or even entire programming languages as our agentic app changes.
I can think of no better way to show this than to add some new features to this simulation, like having those runners show us their thoughts. This is not going to work with that current architecture. We have to add a number of components to make this happen. To show you how you can do all this with a Google Cloud expert agent at your side, please welcome one of my favorite Googlers, Bobby Allen.
Thank you, Richard. Do we have any GKE fans in the house? Can I hear you? Yes, yes, yes. Okay, I'm too hyped now. I got to calm down and do the demo. All right, this simulation is a marathon, but you could use this analogy for any software. We can create exciting things faster than ever before. The world doesn't run on greenfield software, though, where we build new every time. Greenfield is a sprint. Running a system over time requires rigor, focus, and iterative improvement, more like a marathon. I want to show you an example of vibe clouding, where we use the power of agents to upgrade an existing system. Let's focus on upgrading a component in our simulation, the runners, and we'll do that in two ways: control and customization. For greater control, we're going to convert an app from a Cloud Run service to a Google Kubernetes engine or GKE deployment. For greater customization, we'll introduce a fine-tuned or customized model based on Gemma 4 that we also plan to run in the same cluster. Now, in the last demo, you saw Megan use Cloud Assist to debug code. Now we plan to use Cloud Assist to modify infrastructure as code. Here I am in anti-gravity editor with the Cloud Run service manifest that represents the runners. We'll do the runtime conversion and Gemma deployment in a single prompt. Convert this Cloud Run service to the equivalent on GKE with the Gemma 4 model hosted in the same cluster. My IDE is connected to Gemini Cloud Assist via MCP, which gives us access to Google Cloud resources and advice for designing and running applications. In other words, Cloud Assist serves as the translator that turns my intent into infrastructure changes. Cloud Assist helps us do full stack infrastructure deployment. It identifies best practices for running inference on GKE, like the right VLLM configuration for serving and policies for scaling. All right. So our GKE manifest or configuration for our converted app, including Gemma, is now ready. All we'd have to do is say yes to apply the changes. Now, deployed workloads start to appear in the console in 30 seconds or so and take about 10 minutes to finish. So we sped this up a bit for the sake of time so you can see the finished product. Now look, I want you to take this in. I use my voice to tell AI to deploy AI and put it in Kubernetes. Anybody hype about that? I think this is cool. All right. So the two components you see are the converted app, the runner now in GKE, and the Gemma inference server running in the same cluster. All right. This is the portion of the console where you can see details around AI workloads, such as confirmation that we deployed Gemma 4 as we expected. Now, for context, remember that the runners are just one component of the marathon simulation that you saw earlier. All right, let's try this out. So, 100 runners worked fine in testing, but we rolled this out internally to thousands of runners, and we've been seeing some issues. Oh boy. It looks like the runners aren't actually running. At least this time we know Richard didn't break it. Listen, sometimes scale breaks things or slows them down to the point that they seem broken. This is why it helps to have proactive helpers like Cloud Assist to surface issues quickly. Here we are in the Google Cloud Console, and Cloud Assist is already running an investigation on our behalf, and it's identified the problem. Our storage isn't loading the model fast enough. GCS Fuse is great for some use cases, but in this case, we need to also scale quickly, and Lustre is a better option for rapid scale. So we're going to take the Cloud Assist recommendation to deploy this upgraded storage and let it handle the details. Since this will take a few minutes, we're going to go to another instance where Lustre is already deployed. So we're back in our simulation, and we just kicked off a run. Now latency should no longer be a problem. Here's our upgraded simulation with upgraded runners, and the proof of the upgrade with Gemma 4 is that we'll now be able to see how they're feeling and what they're thinking. Let's check it out. All right, counting stormtroopers, I'd probably be doing the same thing. Vegas send music. So look, I don't know about you all, but my thought bubble would probably say something like running today, crawling to the mailbox tomorrow, because I'd be feeling that. But anyway, let's recap a little bit about what you saw. Number one, our intent quickly turns into action, even for existing brownfield systems. Number two, we're proactively notified about issues with specific resolutions. And number three, we can focus on outcomes, not products or features that constantly change. Here's the point. We see a world where agents work with you to take action within the guardrails you set, not just answer questions you have. Don't chat with me about change. Partner with me to safely implement change. This is our vision of an autonomous cloud. Thank you.
Give it up for Bobby. I don't think even he can make vibe clouding happen, so let's not use that. That's not going to get.
No, he can read my internal thoughts when I'm running a race, though.
I have internal thoughts after hearing that phrase.
Okay, so I don't know if we're actually at fully throwaway architectures yet, but our value as developers is taking the learnings from each version that we build and applying them to the next version of our apps. And Gemini Cloud Assist helps us with many of the specifics, even autonomously, so we can focus on the use case and building a great app.
Speaking of use cases for all builders, let's talk about how the agent platform powers up developers and builders wherever they are. First, with Gemini Enterprise, you can create insights from your data sources using pre-built agents from Google, like the Data Insights Agent, or my personal favorites, Notebook LM. Next, your team of users and developers can build rich agentic experience using high, low, no-code interfaces to get value from agentic behavior. And then you can share all these agents securely and at scale with agent platform's built-in governance controls.
Yeah, you know, Richard, we're all developers here. We all flip from high code to no code and back to high code, right?
Is that what you're doing? Well, that is one of your powers.
This is the power of the agent platform. And I know two people can help show their power and build and share all types of agents. So please help me welcome to the stage Ines Envid and Jason Davenport.
Let's see those towels.
All right.
All right.
Here we go. We've built, so far, a fully functional simulation. But we can do even more with the agents we've built. So let's show you why, as developers, no-code agents can be really a powerful tool in your tool belt. And we'll show you how high and no-code agents work together.
All right. First thing we're going to do is we're going to share the Marathon Planner agent in Gemini Enterprise. Then we'll show how all types of users can create their own no-code agents to make work easier, like for me, getting out of meetings at work. But actually doing serious things also, like logistics work, ordering all the water, bananas, and porta potties.
All right. So, Jason, let's pull up all of our Gemini Enterprise-enabled agents. all the agents we've created in Agent Runtime are automatically registered in Agent Registry. They're discoverable by other agents and apps, included here in Gemini Enterprise.
That's pretty cool. So now let's actually see where they're at, right? Here we are in the Gemini Enterprise app, and we can see that the Planner agent is available for us to use. So let's go ahead and give it a shot. Here, I have a test session where I'm planning a marathon for 10,000 runners in Las Vegas. And when we use Gemini Enterprise with our agent, we still get dynamic interfaces back with A2 UI. Our high-code agent features work on both custom apps and standardized surfaces here in Gemini Enterprise.
This is cool. All right, so now let's say that we're ordering things for the race, so water and food and even music to keep people entertained. And we usually just use a very long Google Doc to track all the steps.
It is so long.
Planning marathons as well is a team sport. So our committee usually needs to get many people involved for all the different steps. And it's a lot of thankless work. So let's create an agent to handle the planning and ordering. And we'll give this document as context to the agent. So go ahead and open the Gemini Enterprise Agent Designer.
All right. Here we are in Gemini Enterprise's Agent Designer. We've given a prompt to Gemini Enterprise to create an agent that is an expert at planning and ordering for a race, using this prompt here. And since this takes about a minute for Gemini to create our team, we pre-populated it. And Gemini's design that it created is over here on the right. And if you remember from earlier, agents that you create in Gemini Enterprise are automatically registered back in Agent Registry, so you could use those elsewhere if you want to also.
And with that one prompt, Gemini Enterprise created a whole team of agents for us. So we have the main agent, which coordinates all the planning and ordering with a team of sub-agents that are experts in their specific area. All right, so let's click on the main agent. Notice that Gemini created a detailed set of instructions for the agent we could choose to customize further. Jason, let's give the agent access to our document about ordering supplies as context. And we just need to provide it with the Google Drive link. You see that users don't need to know how to codify this document. Here, we simply give the document as context to the agent and always has access to the up-to-date information. All right, so let's update it.
All right. So now, the moment of truth. Let's come back to our conversation that we have with the Marathon Planner agent. And what we can do is we can actually change the focus of our discussions, in this case to the supply chain agent, then ask it to make a comprehensive plan, including the logistics we need for the race. And what's cool is that now the agents will work together to actually create our plan. We have water and food. We have things like the mileage that things need to be placed. We have entertainment. And most importantly, we have porta potties.
Very important, all those porta potties.
So important.
All right, so this is high-code and no-code agents working together for us to make race planning easier. Great work, Jason. Back to you, Richard and Emma.
How great was that? This whole keynote is camels and porta potties. It's who wrote this? But what is important to take away is that teams of any size, people of any skill level, can actually use agents via Gemini Enterprise. How great is that?
Yeah, they can. So now let's talk about security and governance.
It keeps getting better.
It does. Agents give users and other agents new ways to intentionally or unintentionally expose data and behaviors in ways that we may not want. For example, users shouldn't be able to change financial data. Richard, we already got rally towels for everybody at the race, but this is a race at night, and I want to do more. So let's see if we can actually increase the budget to get glow sticks and maybe some of those really cool nighttime LED sunglasses.
I mean, I love it, but I don't think, I love spending Thomas Kurian's sweet, sweet OpEx money, but I don't feel like we're supposed to, that's not supposed to work.
Yeah, we did, though.
Yeah, not great. Our planner agent should not be able to change the budget. That's obviously some sort of security bug by our developers, and We always talk about shifting left for development, but that's hard, and security is never a lot of fun for devs. Let's be honest, shift left is often code for developers should just do more. It's not sustainable for developers to be responsible for all layers of the stack. We need to shift down instead. That means smarter platforms. We need to provide better ways to give conditional access from agents to humans and agents to agents.
We do. Agent identity gives agents well-defined policies to help ensure that agents can access only what they need, only when they really need it, and nothing more. And Agent Gateway, which gives teams a centralized place to manage all of these policies together.
Platform engineering, we know, is a team sport. We got to work together. To show how an engineering team can be empowered to help build and govern more secure applications in this era of MCP and agents, let's welcome to the stage my friend Ankur Kotwal.
G'day, everyone. As a developer, shifting security down on a multi-agent system has felt like trying to navigate the Vegas Strip at midnight, blindfolded. You don't always know what vulnerabilities are critical or how an attacker might manipulate your planner agent into routing 10,000 marathon runners straight through a Vegas casino. I'm going to show you how to govern agents with easy-to-understand policies. You'll also see how to identify exploitable risks in your code and how to fix them. Our agents have been deployed to Agent Platform. Agent gateways are proxies between agents. We already have a gateway in place for our simulation. Agent Gateway enforces identity and access management policies, or IAM policies, to help ensure that agents are only accessible by approved sources. This is the agent registry. Our planner and simulator agents are already listed here. Each agent instance has an identity, which is automatically generated when the agent is deployed. Now, unlike broad-purpose service accounts, agent identities provide a unique and immutable credential for each individual agent. Think of service accounts like a single all-access hotel key that's shared by the entire marathon event crew. What a bad idea. Agent identities are like having a biometric scanner at every door and are fully auditable. Here we see our policies. These egress agent policies govern outbound traffic from an agent to resources like tools, models, and other agents. Egress policies are the guardrails for our agents. Our gateway is already configured with a strict policy in place, blocking the planner from accessing the open internet. When you're feeding an agent 10,000 live runner profiles and our production API keys, what happens in the planner needs to stay in the planner. But we still have a problem. Emma showed us how she's able to change our budgets. While I appreciate the agent's generous spirit, we can't have it treating our budget like a high roller suite. We're going to add a policy to our planner agent. So we're going to hit create. We'll select our planner agent from this list here. And there we are. The planner agent calls an MCP server with tools for reading and writing to the financial database. So let's go ahead and select our finance MCP server here from this list. And then we're going to go and add a condition. We'll name it read-only finance. And we'll set the read-only value here to true. We'll hit save and we'll hit create. Now this can take about 5 minutes to propagate, so I'm going to switch to a version that I deployed earlier. Now let's try the same prompt that Emma entered. The planner agent is communicating through the agent gateway, and thanks to our new policy, it can no longer call write-enabled tools on the finance MCP server. And there we have it. Sorry, Emma, I'd love to approve the glow sticks and sunglasses, but our zero trust architecture comes with a zero budget policy for impromptu spending. In just a few steps, Agent Platform has enabled us to implement role-based access control for our agents using agent identities and policies. But let's switch gears. Thanks to all of these agentic developer tools, I'm writing a lot of code. But how can I be sure that my code is secure? To show us how to help keep all of our code secure, all from within our developer tools, please welcome to the stage founder and vice president of product at Wiz, Yinon Costica. Give it up for Yinon.
Thanks, Ankur, and for the opportunity to present to the amazing development community here at Next. Wiz is a unified cloud security platform that helps organizations secure everything they build and run. Wiz scans your code and infrastructure to build the security graph that's a living map of your cloud and AI applications. We use rule-based, but also the latest AI models to understand risks and vulnerabilities to the environment. On top of the graph, Wiz uses context and a layer of security agents that accelerates the security work. In yesterday's opening keynote, we showcased the Red Agent. The Red Agent is our friendly pen tester that exploits issues from the outside. Next, we showed the Wiz Green Agent that's a fixer that suggests root cause remediations and starts the dev workflows even directly to our coding agents.
And look, we can see our Marathon Planner agent, the model it runs on, and the tools it can access.
Yes, exactly. This is a full architecture, so while you were building your app, security can easily see what you've built, understand it, without you having to actually explain it to them. So we can see also not only the agent is here, but also there is a full attack path from the internet through this internet exposure all the way to sensitive data behind it. Now, the Red Agent looks at this attack path and validates that the risk is actually exploitable from the outside. You can see that it found an authentication bypass vulnerability, and more than this, you can actually see all of the steps it took in order to find this authentication bypass. So in general, the AI attacker, the Red Agent, is the best AI attacker probing your environment, and it goes far beyond code analysis to focus on real risks to your deployed apps and APIs. Now, with our cloud-to-code inference, we can actually identify the source repo to actually fix it.
Now, as a developer, I want security to meet me where I work, in my dev tools, without going to a security portal. And with Google Cloud and Wiz, I can use any AI tool I want to help with security work.
Perfect. So here we have Cloud Code with Opus, and with Wiz, we want to enable your choice of tools and models as long as you fix and prevent real risks in your applications. And now, we just saw a critical risk to our planner agent that Wiz says we should fix right away. We can use a Wiz skill. You can see here the Wiz remediate that basically I ran earlier to pull all of the risks deployed from this repo. Now, you can see that Wiz found a toxic combination that's a critical risk. You can see 7 distinct security risks that actually created this attack path. Now, the Wiz Green Agent looks at this attack path, and it actually suggests 3 priority fixes to break the attack chain. The first one is to downgrade the AIM privileges. Second is to patch the authentication bypass vulnerability. And the third is to enforce the AI guardrails.
Now, as the human in the loop, I love the control and practical sequencing. So let's go ahead and apply these changes in on.
OK, so now this takes a couple of minutes to run. So I'll switch to one that we've already run just before. And it looks like Cloud Code has already applied all of the fixes. You can see the changes, but you can also see a summary here that it actually found the Terraform to remove the excessive access. It actually found the application code to repatch the authentication bypass vulnerability, and it enforced the AI guardrail. Et voila, basically code findings turned into actionable code fixes, grounded in runtime exposure and actual attack path context. Now we can commit the code, Wiz does a rescan, we can see that it passed, and we're good to go. This is what it means to build faster and safer than ever before.
That was amazing. Thanks, Yinon. That's great. In this demo, Yeah, give it up. In this demo, you saw how Agent Platform enables fine-grained governance of agents with Agent Gateway as a proxy, role-based access control, identities, and policies.
You also saw how Wiz can proactively scan your code for risks, then identify if they are actually exploitable, and guide you on how to fix them, all from your own developer tools.
This is true secure development. We no longer have to choose between developer velocity and security.
Let's do magic.
Take us to the finish line, Richard and Emma.
Great. Let's give it up for Ankur and our special guest, Yinon. That was terrific. Loved it.
It was. It's exciting to see how Gemini Enterprise Agent Platform can empower developers to build production-ready agents. Richard, you know I work in open source, so I'm so excited to share that we've open sourced every line of code that we shared today.
Awesome is that, 100%. Yeah, let's give it away. I'm so excited every developer in this audience can try out the app we built right now, but check out the developer solution we've created for this project. It actually guides you through the architecture, how we built the various pieces of this using Google Cloud, and we even provide links and cloud credits to all the labs that we've built so you can try it yourself. And you can clone that repository, try it out right after the show. If you remember nothing else, though, our agent platform makes the process of building and running these agents the best in any cloud. From the runtime with Agent Cloud, to giving our agents memory and context with our Data Cloud, and the code and frameworks with ADK, and Agent Platform's built-in AI services for tracing and eval. It really is an exciting, awesome, amazing time to build agents with us.
It is. So with all of that, thank you to everyone for joining us here in Las Vegas and on the live stream. Now let's go build.
Oh.